So as an example, let me give you an example that I know that you know how to do. What we're going to do now is figure out which of these two fractions is greater than, less than, or equal to. So we want to sort of put the symbol in between there. What about 1/2 and 4/8? Well, I'm kind of giving you sort of a simpler example in the beginning because I'm trying to illustrate the point, but you can already think about what half of a pizza looks like in your head. Now, what if I took a separate pizza and cut it into 8 slices, but only gave you 4? Well, if I cut it into 8 slices, but gave you only 4 slices, then you know you have half the pizza, right? So these two fractions should be equivalent to one another, and you know that they're equivalent to one another because this is sort of an easier one. But what if I gave you, crazy set of fractions? What if I gave you, 5/17 and then, 7/16? Okay, so which one of those fractions is bigger? I mean, honestly, I'm looking at it right now, and I don't really know exactly which one's bigger either, because you have different denominators. Each pizza's cut into a different number of slices, so it's really hard to figure out who has more pizza, because these are difficult numbers to deal with. So what we're going to do now is sort of go through a nice technique to show you how you can solve those kinds of problems. But for this easier problem, how would you do it? Well, you would just need to find a common denominator between the two. So I'm going to work on the 1/2 here. So 1/2, if I multiply it by 4 on top and bottom, then I'm going to get 1 times 4 is 4, 2 times 4 is 8. Okay, so this is the one fraction, 4/8. The other fraction came from over here, 4/8. You can see that they're equal because we've shown that the first fraction is actually equal to 4/8. The second fraction was already 4/8, so now we can say that they're equal to one another. So these two fractions are equal. They look different, but they're equal. And you know that because we talked about the pizza analogy before. But like I said, let's get into something, a little bit of a harder example that, would be difficult. What if you had 2/3 and 4/7? I don't want to say this is difficult, but certainly, even me, when I look at this, I don't know which one of these fractions is larger or smaller off the top of my head. And that's one thing students sort of think that you're just supposed to know when you get to fractions. It isn't easy to do these things in your head. Even for me, I don't know which one of these things is larger or smaller. It's something you have to get comfortable with. You're not going to be able to look at fractions and add them in your head. You just can't. You've got to do work on paper. So make sure that you're getting that good practice here. So the way that you figure out which one of these is bigger is you need to find a common denominator, but I can't really just work with one of these two numbers. I have to do something with both of them. So I'm going to pick the number 21 as my common denominator, only because I know I can take 3 and multiply by something to give me 21, and I can take 7 and multiply it by something else to give me 21. So over here, 2/3, I'll multiply by 7, okay? And what I will get, 2 times 7 is 14, and 3 times 7 is 21, like this, okay? Now this fraction right here, what if I change this guy around? So we do this one down here. So I'll say 4/7, and I'm going to multiply this one by 3 and by 3. So what I'll have is 4 times 3 is 12 on the top, 7 times 3 is 21 on the bottom. So what I have here is 14 over 21 is my first fraction after I've changed it, and my second one is 12 over 21. Now keep in mind, these fractions are exactly equal to the ones that are up above, but the difference is, because I'm now over the common denominator, I'm over a pizza with basically 21 slices. If I cut a pizza in 21 slices and I give this guy 14 slices, and then I have another pizza and I cut him up into 21 pieces and I give the other guy 12 slices, this guy is going to have more pizza. The guy with 14 slices out of 21 is going to have more. So this fraction is bigger. So this fraction is bigger because this one corresponds to this one and this one goes with this one. So this is the answer. 2/3 is larger. 2/3 is larger than 4/7, but I guarantee you it's very, very difficult for you to look at those two fractions and figure that out in your head. But by transforming them, it becomes very, very simple. It's just like reading numbers. So, it's something to get used to. What if we had 3/5 and 4/7? 3/5 and 4/7. Which one of those fractions is greater than or less than? Okay, Well, I can't really just work with one of them. I'm going to have to work with both. And I'm going to target the number 35 as my common denominator only because I know I can multiply by 5 times something to give me 35. And I can multiply 7 times something to give me 35. So 3/5 I can multiply by 7. And then this fraction would be 7 times 3 is 21. 5 times 7 is 35. So what I'll do here is I'll take 4/7. And because I'm trying to target 35, I'll multiply this by 5 on the top and the bottom. And so ultimately, 5 times 4 is 20. 7 times 5 is 35. So the two fractions that I started with that look different, now I have them in terms of a denominator that's the same, 21/35 and 20/35. So again, if I take a pizza, cut it into 35 pieces, and give one guy only 20 of those pieces, and then I take another pizza and cut it into 35 pieces and give this guy 21 of those pieces, this guy is going to have the most pizza, the guy that has 21 pieces instead of the guy that has 20 pieces. So basically what we've shown is that 21/35 is greater than 20/35, which means that 3/5 is greater than 4/7 because this fraction goes with this one and this one goes with this one. So 3/5 is greater than 4/7. But again, looking at 3/5 and 4/7, I myself do not know which one of those fractions is larger because you can't really visualize. Well, you can visualize cutting them into different pieces, but it's just going to be harder to figure out which one actually has the most amount of stuff there. So don't get too worried if you don't understand which fraction is bigger or smaller. That's normal. That's totally normal. All right, what if we have 1/3 and 1/6? Which one of those fractions is larger? Well, this one's a little bit easier because I have 6 and 3, and I know that I can just work with this fraction because I have 1/3. I can multiply this fraction by 2 to give me 6 as a denominator, which is already the same as this. So 1 times 2 is 2. 3 times 2 is 6. So this guy can stay the same as 1/6. So now you look at these two fractions, 2/6 and 1/6. Which fraction, which person has more pizza or more pie or whatever you want to say? If I cut a pie into 6 pieces, this guy gets 2 of those pieces. If I cut another pie into 6 pieces, this guy only gets 1. So this guy actually has more pizza. So we've learned that 2/6 is greater than 1/6, which means that 1/3 is greater than 1/6 because the 2/6 was equivalent to the 1/3. So I'm just sort of rewriting this to sort of show you that this follows from it. So the 1/3 is greater than the 1/6. So it's just a matter of trying to find those common denominators, and that's why it's so important. It helps you visualize which fraction is larger and smaller, and it's just absolutely required in order to add any of these fractions together. Basically puts the fractions on equal footing. Now the final thing I'll say before we close in this section is that up till now we've been dealing with numbers. Numbers are great. Fractions, you're using fractions with numbers all your life, and you will be using fractions with numbers all your life. But a lot of people, when they start to look at an algebra expression that has a fraction, in other words, with letters in there, variables, like x over y or something, they'll get worried about it, and they'll think it's different, and they'll think that, oh, now I have letters, everything's totally different now, I don't understand how to deal with that. But you need to take a deep breath and realize that all of these rules that I'm showing you, all of them can be applied to any kind of fraction. It doesn't matter if there's a variable in it or not. So as an example about that, let's take a look at 1 over x and 1 over y. So these are two fractions you might look at, prior to algebra and say, oh my goodness, how do I find the common denominator here? What you got to realize is that this denominator is a number. I just don't know what it is. This denominator is also a number. I just don't know what it is. So if I take 1 over x, let me rewrite my fractions. What common denominator can I pick? Well, if I take this denominator and multiply by x, if I take this one and multiply by y, I can multiply these fractions by anything I want, even letters, even variables, as long as I do it to the top and the bottom and make them match, because then I haven't changed anything. And then if I do that, the fraction I'll get on the top, 1 times y will be y, x times y will be just xy. You can't do anything more than just write it as xy. On this guy, you'll have x on the top, and then you'll have xy on the bottom. Y times x is the same as x times y. So now look at what we have. We have two fractions, but the denominator is the same, x times y. So when you have a denominator in a fraction, we've been always dealing with numbers, making the denominator a number. But when you're dealing with fractions with variables, it doesn't really matter as long as the two denominators are the same. the same letters, it looks exactly the same, then we say that they have a common denominator. So these two fractions, you could add them together now because you have a common denominator, for instance. Same as we do with numbers. So don't get too worried about it if you see something different. What if you have 1 over 2a and another fraction 2 over a, and you want to find a common denominator? So you look at this and you're like, oh my gosh, this is a difficult thing because I have letters in there. How do I do it? But just think about it for a second. If I only work with the bottom fraction, 2 over a, what if I multiply this fraction by 2 and this fraction by 2? Top and bottom by 2 is what I'm trying to say. 2 times 2 is 4. A times 2 is just a times 2. You can rewrite that as 2a. 2 times a multiplied by a. And this fraction I can leave alone as 1 over 2a. Now these two fractions, they have the same denominator. The denominator is 2 times a, whatever a is. I have no idea what a is, but I know that it's in the denominator and it matches, so they're common. So 1 over 2a and 4 over 2a. These fractions could be added, they could be subtracted, and in fact, I could even tell you that 4 over 2a is greater than this one because I have 4 pieces out of whatever this is, and here I only have 1 piece out of whatever that is. So it's very, very useful. Do one more final one. What if I have 2 over 3x and 3 over 2y? And I want to find a common denominator between the two. Well, like we said before with numbers, and you know, if you get stuck and you can't find a nice common denominator, you can always just multiply the denominators together to give you your common denominator. We did that up here actually, x and y. The common denominator we ended up with was just x times y, and that will always work as a denominator between the fractions if you can't find anything smaller. So if we take 2 over 3x and we'll take 3 over 2y, what can I use as a common denominator? What could I use as a common denominator? Well, if I multiply this guy by 2y on the top and the bottom, and multiply this 3x on the top and the bottom, I'm basically just taking this denominator and multiplying by this one, and I'm taking this denominator and multiplying by the other one. Then on the bottom, I'm going to have 3 times 2 is 6, x times y is xy, that's all you can do with that. 2 times 2 is 4, and then you have your y sitting out here. And then over in the bottom, 3 times 2 is 6, x times y is xy, 3 times 3 is 9 times x. So here we go. And I know we haven't gotten into a lot of multiplication and things with letters and numbers in there yet, but I'm just kind of giving you a preview. Multiply the numbers, the letters stay multiplied also, but you can't do anything more here. Now you have two denominators that are the same. The numerators, or whatever they fall out to be, 4y over 6xy and 9x over 6xy. And that's going to be your two common denominators. So these two fractions, this guy is exactly equivalent to this guy is exactly equivalent to that. So, I'm Jason. I hope you've learned something in this section. Finding a common denominator is incredibly important. You're going to use it all through algebra, all through real life even, with manipulating fractions, and on beyond. It's something that you're always going to deal with. It's so important. So practice it, get good at it. It's absolutely indispensable for adding and subtracting fractions. We'll get into that in the next section. And just keep in mind, when you have letters and things in the bottom, all the same things apply. Here, all I did was I took and multiplied the two denominators together to give us our new one, and we were doing problems just like that before with numbers. So it's not a huge stretch to realize that you can use the same technique here. I'm Jason. Practice your problems. You'll get better each step along the way.